I guess we can start. So basically, maybe I'll go over the components first, and then I can talk about the software, and then I can go over some basic cuts. Then more advanced cuts would be like alignment and realignment, and that's if you want to make like multiple layer stack-ups of parts. Then if you want to like take it out, put it in the heat press, do some processing, then you want to be able to realign it when you put it back in for like release cut or something else, then that's usually the most difficult part. But yeah, so I'll go over the main components. So the laser is in here. Usually it is a UV laser, so it is dangerous if you are looking at the laser directly. And it also is a I guess class 3 or 4. I think when they originally proposed this, they were trying to pitch as a class 1 laser, but I guess they didn't let them.
I think it's class 4, right? It should be.
Yeah, yeah. But basically, this is for your safety. The little screen windows you can kind of look in, but they'll protect your eyes from the UV. If for some reason you need to maintain it, and you need to take off the enclosure and you're realigning the lasers and playing around with the optics, then there are safety glasses. It's basically the same material but in glasses form, and you can get those up here. But I don't think you'll have to do that. I hope not. If you do, then just contact me or Greg and we can help you out with that. But that's mostly for if you need to realign the laser or the laser for some reason needs servicing in the future. So there is a magnetic safety here. Basically, when the door is closed, the magnetic safety is in contact and the laser is non-operable. So no matter what you do, you can't use the laser as long as the door is closed. I mean, as long as the door is open. If it's closed, you can turn it on and you can do everything. So a brief overview of what's inside. In the back here is the actual laser itself. This is the UV 355 nanometer laser. This is basically what's doing all of the work, and everything around it is just the optics. So it'll go through 2 beam expanders, and it'll redirect the beam path into this black box, which is the galvanometer. And this is basically what's controlling the laser to cut out some arbitrary pattern that you want to. And the most critical part of this path is the beam alignment through all of the optics into the galvo. If the beam alignment is not close to perfectly perpendicular to the F theta lens, which comes into the galvo, then that's where a lot of the misalignment issues will arise. So that's kind of the most critical alignment for the laser. You'll see here also that there are a couple other lasers. This isn't part of the actual laser beam path. This is for a red laser, which you can see here. This is basically just for visualizing your path. When you go to cut, you'll soon see that you can use that for testing the alignment, just doing like some test cuts to see that what you're cutting is actually what you want it to cut. So the laser will be focused in the galvo, and that's what's cutting your actual part. The thing to the right of this is the microscope lens. This is for visualizing all of your parts and for focusing the laser on your part that you're cutting. It's connected to a pixel length camera, which will be fed through to the computers, and you can focus and refocus the microscope just on using this right here. This won't actually focus the Z stage height to the laser itself. This is just for zooming the microscope. If you want to raise and lower the stage for focusing your piece at the workpiece, then you will want to use this Z adjustment knob right here. I believe it's clockwise for raising it up. I think it's written right here. Yeah, so clockwise is raising the stage up, and counterclockwise is lowering this stage. But I think you'll get a feel for it once you actually start playing around with it. The other stage adjustment is a Z rotation. So when you're going in for the alignment cut, if you place the piece in and it's slightly offset, then you want to be able to correct the stage via rotation to realign the piece with what you're cutting. So the two main knobs are down here. One is this fine adjustment knob. I can't remember the direction of rotation, but this is for very fine, like probably single digit or less than single digit rotation alignments. If you want to make more coarse adjustments, then what you want to do is loosen this collar first to make a really coarse adjustment first, and then by visualizing your stage and your piece in the camera through the computer itself, then once you get it close to where you want it aligned, then you can use the Z rotation fine adjustment. It's really critical to do the coarse adjustment first before the fine, because there is a little set screw inside this fine adjustment rotation to where if you crank it too much, then that'll slowly get loosened, and that will make the stage a little bit, it'll have a lot of play, and that'll mess up the alignment of your cuts in the future. So I'll demonstrate this a little bit. Basically, turn this coarse adjustment collar counterclockwise, and this will loosen the stage, and you can rotate this very freely without any friction. Once you realign the stage to about where you want it to be, then you want to tighten this collar, and then you can go in with the fine adjustment to do any further rotations. So that's most of the mechanics. The stage itself here, this is all powered by the control boxes over there, and all of the controls that you'll need for controlling this will be from the control boxes in the computer. But we can move on to those right now. Do you have any questions so far? We have a vacuum right here. You can adjust this for just getting any debris off of your piece while you're cutting. I guess typically with any laser cutter, after you've cut a piece, you probably want to let this run for a bit, just so that you're not inhaling any fumes afterwards. So that's most of the hardware. Let's move on to the control boxes and the computer. So the main pieces are one, the laser control box. So this is what controls the power and pulse frequency of the laser itself. This is directly connected to the laser, and the laser box is also connected to this box right here, which is the coolant. So it's a radiator for circulating coolant up and through the control box and the laser. This is what keeps the laser cool, and if for some reason you ever notice any sort of like rattling noise, or if you see the temperature increasing, then that might be time for you to replace the coolant in the box. And this is deionized water. We have a supply of it underneath the cabinet, but if you need that, then you can come get it. This is the computer for controlling all of the software, and that's kind of our workstation right here. And the final critical box is this stage right here. This is the stage control that controls the bottom stage here. And I think the main controls for this are mostly the stage jogs. So this will control X, Y, Z, or just X, Y in the planar direction of the stage. So this is very useful for aligning your part to the microscope and your galvo. This is the jog speed of your stage jog. This is very non-linear, so you have to be a bit careful when you're adjusting this, because a slight adjustment might cause it to just shift very quickly. Yes, and then the origin shift will shift your stage from the camera view to the actual laser stage. So once you align your part in the camera view, then you can press origin shift to shift it to the galvo where you actually cut it. There are a few other features on this box that we will probably go into. The main ones are the zero origin. So zero origin will zero your origin once you center your piece on wherever you want to cut. Home stage will, if you happen to want to inspect your part away from your origin, then this will move your piece away from where you got to set the origin. But if you want to go back to the origin, then you can just press home stage. There also is a special feature on this box that is related to the zero origin. After I think around 2 or 3 hours, if you're doing very long cuts, then what typically happens is that the laser cutting will start to shift from where you had originally set your origin. We call that a thermal drift. So after maybe, I think a good rule of thumb is like 2 to 3 hours, you will want to recenter your origin. But an easy way to do that is to hold this zero origin button for 3 seconds or more, and at the place that you would set your origin, and that'll automatically run a procedure where it'll just reset your origin at your original origin. So in the past, you would have to do some calculations where you cut a crosshair at one piece, and then you'd shift to your camera and kind of have to calculate the offset from your original origin to the thermally drifted one, but you no longer have to do that. All you have to do is, like, after 3 hours, just go back to your original origin and press this for like 3 or more seconds, and then everything should be all set. So that's the main overview of all of these buttons. We really don't touch any of these other ones. I think that's kind of a touch at your own risk thing. This stage box we usually keep on 24/7, and this one will turn off after we use it each day. One thing about this is that since this is directly controlling both the laser and the coolant box, it's kind of important for you to let the system warm up first and also cool down. So if you don't let the system warm up sufficiently, then the coolant isn't flowing into the laser for long enough. So if you suddenly go into a very high-powered cut, then you're generating a lot of heat, and that could damage the laser. Also, if you turn off the box too quickly after using the laser, then the same issue could arise. If you're using the laser for a very long time, then it's generating a lot of heat, and maybe a few minutes after, there will still be a significant amount of residual heat. So if you turn off the box, then the coolant will stop running, and the residual heat could damage the internal crystal or some of the electronic components inside. So I guess it's very important to just let the system warm up for, say, just to be safe, like 10 or 15 minutes before, and similarly afterwards, I would err on the side of caution, so maybe 15 to 20 minutes before you shut off the box. So that's an overview of the hardware. Next we'll go into the software that we use. So the main ones we use are ProLaze 7, so that's this one right here. So this is the interface where your laser is being commanded a certain drawing that you want to cut on your piece. The main controls are mark control, and marking material. So really the only boxes that we'll touch are the number of parts in the batch. This indicates the number of passes that you're cutting a certain piece. So let's say you want to cut a piece with like 1,000 passes, then you would have 1,000 passes. You'd have 1,000 repeats of the cut that you're making. Continuous is, I actually don't know what that is, so ignore that. And then for the materials interface, the only ones we check off are speed and frequency in the pass 1 row, so we only change these two. Everything else does not do anything, and changing the power does not change the power of the laser. I will show you, actually I can show you right now. So speaking of, we should turn this on and let it warm up first. So this is the master switch. And also just for safety, we usually turn the laser enable key to off after we switch it off. If you want to turn it on, then just turn it on. So if you want to change the power of the laser, then you can't do it here. So where do you go? You go into the box interface. So we go into menu, go into menu, then pulse setting, and you'll want to go all the way down to pulse energy. And to change it, you can press enter, and you can use this wheel to go up and down to whatever you want. And if there's not a good recipe for any material that you want, then I think it's best practice to just do like a bunch of different test cuts on a material, and you might need to play around with the power. If you really want to be detailed about it, you can use this power meter, and you can measure the watts of the power for some given power setting. But I think by trial and error, you can usually get pretty far. So I guess I'll go over while it's warming up what the main features are in the menu for this one. So the main one we use for this menu setting is pulse energy. It's good to know, just for reference, to keep in mind what the default settings for everything is. So for pulse setting, the default is the QSW key should be enabled. That'll allow you to actually run whatever you're doing. Frequency and gate should be set to external. What that means is that it's being controlled by an external software, I believe, and it's not internally always on. I think rep rate is controlled by the ProWay software, so you're changing the frequency there. Off time, I think this is always at 600 nanoseconds. And then pulse energy. And then I don't think we ever touch this, but I guess enable is the default. And then the other menu that we look at is the diode setting. So current, the IS is something that you will change. This can also help you fine-tune the power. So for example, changing the current to a lower current will reduce the power, and in combination with setting the speed and the frequency and also the actual laser power, you can achieve some variation of fine-tuning for the power. But that's also something with it's somewhat arbitrary. If you really want to get into it, then we can use the power meter. But usually we have a plethora of already fine-tuned laser settings and some side shape on the drum. So I don't think you need to play around with it too much. So that's one thing that you probably will need to change. Other than that, these are all just temperature readings. These are sometimes good to monitor. There are some temperature limits that are set in the box that in the past we've had some errors. So if for some reason you ever get a temperature warning, then these might be some things to look into. This is the ambient temperature of the laser, I believe. I think it's the temperature of the coolant box. If you want to look at the crystal temperatures, then you would go into harmonic setting, and those are showing the second harmonic generator and third harmonic generator crystal temperatures, and these are the limits that are set. In the past we've had issues with these. I think it should be fine for now, but if for some reason you get a temperature error, then this is the menu we'll want to look at. But if something happens, then just come get me or Greg. Other than that, I think those are the main settings for the laser. Then in terms of the other buttons, this should always be on. This is mostly for menu selection. And then these buttons we will use. This is opening the shutter of the laser, so letting the laser go through. And then this is actually turning the laser on. So the order of operations usually when we want to proceed with the cut, we want to open the shutter first and then turn on the laser, because otherwise the laser is just like cutting the shutter itself. And then similarly when we turn it off, we want to turn off the laser first and then turn off the shutter. So we'll demonstrate that in a bit, but that's the order of operations. What else is useful? There are these 3 light boxes that control the light for the microscope. Their mileage may vary. I kind of just like using the backlight a lot. I find that that's the best for visualizing the parts on the computer. These other lights just have different lighting features. I don't find this one too helpful. And I think this one is the same, but you can just play around with it. Okay, so I gave you an overview of ProLays. This is what the software is going to Sorry?
Switch the vacuum.
Oh, yes. So also important, the vacuum will, you want to turn this on before every cut, just so that you're extracting all the fumes and the debris. The alignment laser, turning this on, you can see that shows up that alignment laser that I was talking about before. So this is really useful for visualizing the cuts. So the other important software that we use is PixelLink. Sometimes if it's left open, then it won't connect to the actual camera. So PixelLink is what's visualizing your piece on the part, and it's useful for focusing the piece to the actual laser, and I'll demonstrate that in a bit. So exposure time is useful for adjusting the brightness of the piece. I can put something in to see. Okay, so to demonstrate the camera, we're just going to put a stainless steel sample inside. So to fix it in, there's this nice microscope slide fixture. You want to push the piece to the top left corner, and then you can use this arm to lock it in place, and it should be secure. And usually, so I like to use the backlight, and as you can see right now, the piece is under the galvo, and we want to shift it to the microscope to visualize it on the computer. So to do that, we press origin shift. And as you can see right here, the microscope light is kind of offset. So if we want to adjust that, then we can use the stage jog to kind of adjust the lights to where we want it to be. So let's try to get it centered on the piece. So that looks decent. So if we look at this screen right here, it is quite overexposed. So one thing we could do is adjust this exposure. But usually what I like to do first is I like to adjust the microscope. So for the best focus, I like to have the zoom at the max, which is 6.5. We can also zoom out using this. But if you want the most accurate focus, I think we try to have it at the most zoomed position. And looking at both your Z right here and also your microscope right here, we can use the Z adjustment knob to focus the piece on the microscope. So that looks pretty good. You can adjust this exposure so that it's not so bright, and as you can see, it's quite well focused. So since we moved the stage to the center of the piece, what we want to do is zero the origin when we go to cut. So we can just press zero origin, and now our origin was set at roughly the center of the piece. If we want to demonstrate the home stage button, we can kind of shift the piece offset. As you can see, it's now off the center, but we can go back to where we set the origin by pressing home stage. So now that we have focused the piece on our microscope, this basically ensures that when we go to cut the piece, that the laser will be focused on the surface of the material and that it'll cut at the laser focus. For more complicated parts, when we're cutting through very thick material, you might want to play around with refocusing the Z-stage height after a certain number of passes, because your piece will just be fixed at that surface focus. So if you're cutting deeper, then you may want to readjust the stage to set it higher so that you're refocusing at a deeper point in the material. This can be calculated by measuring the thickness of the material and the number of passes that you're doing on your part and seeing how much roughly you might have cut, and this can be kind of adjusted to your own needs. So before we go to cut the material, we want to load a DXF file into the ProLaze software. So to do that, we want to right click on ProLaze, and we want to set a new layer, click OK, and we can accept the defaults. On this layer, we want to create a new object and a new graphic. You can name it whatever you'd like. Let's name it Demo. Click OK. And this properties menu is where you'll set a lot of the cut features for your part. So to select a cut file, you click File. I will just select a demo cut file that I have. And let that load. Something I like to do is I like to check both Show Toolpath and Toolpath Optimize. By clicking these, it'll optimize the toolpath, and when you see it in ProLaze, it'll show the toolpath for which the laser will be cutting. This one is kind of important because sometimes if you have a drawing, there may be some artifacts that have not been deleted entirely, and by clicking Show Toolpath, you might be able to debug those just in case. Everything else is typically set to default. For fill control, if you just want to cut the outline, then you can select outline only. If you wanted to raster a surface and fill in a enclosed drawing, then you can select patch fill only. Or if you want the outline as well, you can select outline and fill. For fill settings, this will be what you're setting for the density of the lines that you're cutting inside of this cut. You can select the number of crosshatches. So basically the default is that you're just only cutting in one direction in 90 degrees. But let's say you want a crosshatch, you can select two number of crosshatches. So this will cut both 90 degrees and 180 degrees to fill in your piece. Inverted fill will select the inversion of your enclosed area, and I typically like to select bidirectional if you're doing a fill pattern, so that you're cutting both up and down and not just one way. For now, we will just do an outline. And in terms of this properties demo, or in terms of this properties menu, the only other menu that you'll need to look at is the orientation and sizing. We want to select real XY and select the correct units for your drawing. All of our drawings are typically in millimeters, so I'll select millimeters. Usually this X justification, Y justification
will only need to be altered if your origin of the drawing is not directly in the center of your piece. But for best practices, I would probably center the origin of your drawing at the center of your piece. So everything should be set for cutting an outline of our piece, and we'll click OK. And as you can see, what we're drawing here is a square box with some alignment holes, and we also have 3 crosshairs, 1 at the center and 2 at the right and left. These crosshairs will become important when you want to do any sort of alignment cuts or realignment for release cuts in the future. These crosshairs will be your reference crosshairs for realigning the piece when you do the release cut. So we should be ready to go and cut. What we can do is we can set some of the speed, frequency, and passes for a given arbitrary material. This one I will just try 25 centimeters per second at 25 kilohertz, and let's just say 300 passes for stainless steel. So everything here should be set. What we want to do is move over to the workpiece. So we visualized and refocused our material at the camera, but now we want to shift the piece from the camera to the galvo. So we want to press origin shift. Usually when I'm shifting, I'll just turn off all the backlights and microscope lights just to conserve energy. And once we've shifted from the camera to the galvo, I like to turn on the alignment laser just to see where we will actually be cutting on the galvo. And what we can do is do a little test cut to make sure that what we're cutting is actually on the material surface. So with the alignment laser on, we can just click mark with the door open to make sure that the laser will not be on or cutting anything. So let's click mark, and as you can see, the red laser will draw the outline of the piece that we want to cut, and the laser isn't moving off of the material, so this is exactly as we anticipated. One thing to note is that what you're seeing here with the red laser, it will be slightly wider than the actual cut of your material, so that is due to the wavelength differences between the red laser and the UV laser itself. So if you want to squeeze in a part into kind of a tight space, then don't be too concerned if the red dot is slightly outside of what you want to cut. It'll probably be okay. But if you want to be safe, then anything that's following this red line is probably safe to cut instead. So before we actually make the cut, I want to show some laser features for the red dot alignment. This will be good for kind of just extra insurance that you're cutting in the material location that you want. So we can go into diagnostics, galvo tracking, and what selecting this does is that it'll turn your mouse into kind of a cursor for the red dot. So by moving the mouse here, you can see the red dot is also following the mouse. So on the screen, I'm kind of drawing circles, and the red dot is following this indicator. So we can kind of trace the outline of our piece we want to cut, and this will just give us some extra insurance that we're cutting inside the material that we want to. So once we've done visualizing the red dot laser, we want to deselect the galvo tracking and also click center galvos, and this will bring the red dot back to the origin that we want it to. So again, if for some reason the stage jogs off of where we wanted our origin to be, we can again hit home stage, and this will center the red dot to where we wanted it to be for our origin piece. Okay, so I think we've done everything that we need in preparation for the cut. What we want to do is turn off the alignment laser and turn on the vacuum. We can then shut the door and you'll hear a click of the door that will make sure that you have engaged the safety and you can now operate the laser. So what we want to do is turn the laser enable on. We have turned on the vacuum, we shut off all the lights just to conserve energy, and we can turn on the shutter first. This will open the shutter of the laser, and we can turn LED on, that will turn the laser on itself. And we want to wait until the IA current has reached its maximum. This may take a second or so, but if you start your cut before that, then you're not getting the full laser power that we want it to. So make sure you wait a couple seconds until your current has reached its desired maximum. So after you've seen the current reach its maximum, you can hit mark. And while it's cutting, this abort symbol will be up. So if for some reason you need to abort the cut, you can just hit abort and it'll cut off everything. So the way you know that you're cutting your part correctly is if you look in the window with the laser, you will see a bluish green light illuminating on your part, and that's how you know that the laser is actually cutting. You can probably cut the water above this table. So once you see that the laser starts to shine through the material, you can see it reflect on the bottom, and it's usually cut, but just to be safe, you might want to do a few extra passes. Okay, good? Yeah. So as you can see, the laser is kind of going through the part, and it's very much highlighted underneath, so we know that the cut should be cut. And we can just abort the part, and to turn off the laser, we want to turn off the laser, the LED first, and then the shutter. We can wait a few seconds for the vacuum to collect any debris and any fumes. Then we can turn off the vacuum and take out the part. You can probably cut this too.
Yeah.
So we've successfully cut out our outline. What I want to do now is demonstrate a alignment cut. So as you can see on the part, we've cut these 3 crosshairs, and what we want to do is realign the piece by using these crosshairs as a reference so that we can cut the same outline. So we'll put this back in. What we want to do is on the backlight and move the piece back to the camera so that we can visualize where our piece is in reference to the crosshairs. So originally it might be difficult to see the crosshairs, so you can zoom out with the microscope. You may need to play around with the exposure. But as you can see, we're not completely centered on the center origin since we've lifted up and replaced the part on the gel pack. So we can use, again, the stage jog and the jog speed to roughly align our crosshairs with the crosshair on the pixel length capture. Sometimes this crosshair on pixel length may disappear. You can go into the effects tab of the software and select crosshair. And you can play around with the color too. I find white to be the most clear. So we'll go back into controls and we'll try to align both the left and right crosshairs to get them aligned perfectly. So to do that, I like to always have it on the most zoomed position. We can roughly eyeball the center crosshair so that it is roughly aligned. And first, let's go to the rightmost crosshair to see what the alignment is. So we'll use the job stage to go to the rightmost crosshair. Actually, it's quite good.
Oops.
Okay, maybe I'll do it. Okay, so let's go back to the center now that we've positioned it in a more offset rotation. Let's again realign the camera view with the center crosshair. And let's go to the farmost right crosshair to visualize our rotation. So as you can see, it's so rotated that we cannot even see it on the camera. So let's zoom out a little bit so that we can get a more clearer picture. And let's try to find this is the rightmost one. We can zoom back in. And already you can see that the crosshair is kind of shifted at an angle from the white crosshair. So what we can do is, again, use this coarse collar adjustment. So loosen it by turning it counterclockwise and roughly rotate it to where it may be more straight. So this looks a bit better. I won't touch the fine alignment yet, just because we may want to adjust it after we look at the leftmost side first. So let's go back to our home stage where we set the origin to see how we did. So we are still a bit off. So we'll want to go back to the origin, roughly align it, and we can reset our origin by hitting 0 origin. So at this point, it's kind of visualizing by going to the left crosshair and the right crosshair to see how well it's aligned rotationally. So just because this first initial one was a very coarse adjustment, let's go back to the right crosshair to see how we did. So already it's much better. Still, this is a bit coarse for the rotational alignment. So again, we'll go back to our coarse adjustment and rotate it until it's about aligned. And then again, we will go back to the home stage to realign our origin. So let's 0 origin to realign the newly rotated origin. And let's go back to the right side again, just to see. So this looks quite good. Maybe we could do some fine adjustment with the rotation. So let's go into this fine rotation adjustment to do some fine tuning. And as you can see, the right crosshair looks fairly well aligned. So now that this one is aligned, let's go back to the origin to make sure that it hasn't shifted. That looks pretty good. And just to double check, let's go to the leftmost crosshair to make sure that it is also aligned symmetrically. So looking at the left crosshair, it is also quite well aligned. So now we have achieved alignment after cutting our original piece. So usually after we perform a cut and we want to go back for realignment, I think even if we haven't performed a long cut, I may like to just reset the thermal drift for the origin. So it's a very quick process. I'll demonstrate it by holding the 0 origin button for 3 or more seconds. And you'll know it was set when the x and y limits will blink for a period of time. So we've centered our origin on the crosshairs and we've aligned it rotationally. So after this, the procedure is the same as before. If you want to cut your piece, again, we can turn off our backlight. We can shift the stage from the camera to the galvo by hitting origin shift. We can turn on the alignment laser. And we can do a test mark to visualize our cut. I think that's it.